In this video, we're going to apply the fundamental theorem of calculus to find the values of x for which the integral from 0 to x squared minus 4x e to the minus t squared dt is increasing. Let's start by calling this integral f of x. Capital F of x is equal to integral from 0 to x squared minus 4x e to the minus t squared dt. Recall the fundamental theorem of calculus, FTC, ddx of the integral from c to g of x, f of t dt. Derivative cancels the integral. The upper limit g of x gets substituted for t. So we get f of g of x. Don't forget to multiply by the derivative of the upper limit using the chain rule. That's g prime of x. So the strategy will be, number one, apply FTC plus chain rule to find f prime of x. Step 2, set f prime of x equal to 0 to find critical points. That's going back to calculus 1, differential calculus, to find critical points. Step 3, apply first derivative test to find values of x where the function is increasing, f of x increasing or decreasing. All right, let's do that. So what we have is f prime of x is equal to 0 to x squared minus 4x e to the minus t squared dt. F prime of x is equal to ddx of integral from 0 to x squared minus 4x e to the minus t squared dt. Now we apply the FTC plus the chain rule. F prime of x is equal to derivative cancels the integral, substitute x squared minus 4x. This goes in for t, substitute that for t, and multiply by the derivative of the upper limit. So that's going to give us e to the minus bracket x squared minus 4x all squared times the derivative of the upper limit, the derivative of x squared minus 4x. That's going to give us 2x minus 4, applying the power rule. All right, so now we want to find the critical point. So we set f prime of x equal to 0. We get 0 is equal to e to the minus x squared minus 4x all squared times 2x minus 4. Now it's clear that a negative exponential is never 0. In fact, it's always positive. So e to the minus x squared minus 4x squared is always larger than 0. So that's not going to make any contributions to critical points. So it's sufficient to make 2x minus 4 equal to 0 to find your critical point. 2x minus 4 equals 0. That gives us x equals 2. This is a critical point that makes f prime of x equal to 0. All right, so now let's find regions of increase and decrease for f of x by applying the first derivative test. The only critical point we have is x equals 2. So let's do the first derivative test. Let's draw a line. Here is x equals 2, x less than 2, x bigger than 2. So when x is less than 2, for example, x equals 1, let's plug that into the first derivative. F prime of 1, that's going to give us e to the minus 1 minus 4 is negative 3 all squared times 2 minus 4 is negative 2. So we get minus 2 e to the minus 9. That's minus 2 over e to the 9. That's negative. That's less than 0. So f prime of 1 is less than 0. That means that f of x is decreasing. The derivative is negative. That means the function is decreasing. So the terminology is very important here. F prime of x is negative. That implies that capital F of x is decreasing. Now let's pick a point x larger than 2. For example, x equals, say, 4. Then f prime of 4 is going to be e to the minus. 4 squared is 16 minus 16, that's going to be 0, all squared, times 8 minus 4 is 4. That's just going to give us 4. 4 is larger than 0. That means that f prime of x is larger than 0, so the derivative is positive. F prime of x is larger than 0. That implies that the function capital F of x is increasing. So the function is increasing. All right, so let's do some review. The function capital F of x, integral from 0 to x squared minus 4x e to the minus t squared dt, is increasing on the interval 2 to infinity. We saw that on last page when we did our first derivative test. All right, and the key concept is when x is larger than 2, f prime of x is larger than 0, the derivative is positive, which means capital F of x is increasing. So basically, we did 3 steps. Number 1, find f prime of x by applying FTC plus chain rule. That was done. Number 2, set the derivative equal to 0, set f prime of x equal to 0 to find critical x value. We also did that. Number 3, find where f of x is increasing by applying first derivative test. That was also done. All right, thanks.